Hi, hello, good morning. Namaskar, salam alaikum. Your Reshma Physics came in front of you to take the basics of reflection of light at curved surfaces, part 4. Now, in today's class, let us discuss how to draw the ray diagrams when object is placed in different positions. So, in yesterday's or last video, we learned the rules to draw the ray diagrams. So here I'm writing the rules. Okay, I'm writing the rules here. First, rule 1. What we said, rule 1, I'm drawing only diagrams. I took concave mirror. Yesterday I was clear with you. We are talking about concave mirror, pole, principal axis, right? Center of curvature, focal point. First we have to point out this. Okay, and then let us take a light ray coming parallel to the principal axis. After incident on the reflecting surface of concave mirror, it reflects and passes through the focus. This is incident ray, a reflected ray, right? Now the second rule. The second rule, concave mirror I took. I identified all the positions such as the pole, which is the center of curved surface, principal axis, center of curvature, focus. Okay. The rays which are focused or passes through the focus. The light rays which passes through the focus after reflection, this is reflected ray, incident ray, they travel parallel to the principal axis. Now third one. Third one what we discussed. Now first let us draw the concave mirror. Right. Pole, focus, center of curvature, principal axis. Now rays which are focused or travel towards the center of curvature, after reflection they retraces the original path. Okay, this is incident ray. Now this arrow indicates the reflected ray. Similarly the fourth one also. So pole, focus, center of curvature, principal axis. Correct? Now, the rays which are incident with a certain angle on the reflecting surface, they reflect back with the same angle. That is I equal to R equal to theta. They reflect back with the same angle. Right? These are the rules. Now we are following these rules. Here, object is placed at different positions, I say. Here, for your idea, I'm writing the positions. Now, concave mirror. We are talking for concave mirror. Ray diagrams we are drawing for concave. First, identify pole, focus, center of curvature, principal axis. Right? Second, principal axis. Now, position 1, infinity. Right? Object is placed at infinity. Position 2, object is placed beyond the center of curvature. Position 3. Object is placed at the center of curvature. Position 4. Object is placed between C and F or in front of center of curvature. Position 5. Object is placed at focal point. Position 6. Object is placed between F and B. Now these object positions we are talking. Okay. Now first, when object is placed at infinity. The first position, when object is placed at infinity. Now, see. First I am drawing concave mirror, polishing the convex surface, pole, okay, focus point, center of curvature, principal axis, right? Now from infinity, object is at infinity. So what happens? Let us see. When object is at infinity, we get parallel rays. Parallel rays means what I said? The rays which travel parallel to the principal axis. Now these rays, now here at reflecting surface, they reflect and pass through the focal point. Right? So, now what we are discussing? Object at infinity. Okay? When object is at infinity, the rays travel parallel to the principal axis. Now what we are saying, when they travel parallel to the principal axis, according to rule 1, they pass through the focal point. So they are passing through the focal point. Right? Clear? Now, position of image. Now I am drawing the two rays. Right? Like this. Focal point after reflection. Focal point only. Ray 1 or ray 2. Okay. Now, position of image. Now you say at focus. Position of image at focus. Next, nature of image. Nature of image, concave mirror, real, right? Inverted, extremely diminished. Diminished means very small size, almost points. Extremely diminished we say. Very small size compared to object size. Okay, this is first position. What is the first position? At infinity. Rays come parallel to the principal axis. After reflection, they pass through the focus. Okay, position of image, it forms at focus. Image forms at focus. And the nature of image is real, inverted, extremely diminished. Right? Position 1 completed. Now let us move to the position 2. Right? When object is placed behind center of curvature, center of curvature C. First, on white drawing sheet, you draw concave mirror. Then identify all the points: pole, focus, center of curvature, principal axis. Right? Now, where is object kept? Object is kept behind. Behind means backside. Behind the center of curvature. Now it is kept on the axis. In first case, it is at some infinity. Now object is, this is object behind the center of curvature. Now see, ray 1 parallel to the principal axis. After reflection, they pass through the focus as per rule 1. They pass through the focus. Now, let us draw another ray also. Okay. When we draw another ray, let us think that they are passing through focus. Rule 2. When they pass through the focus, what happens? After reflection, they travel parallel to the principal axis. Right? 2 rays I draw. One parallel ray. Rule 1. They are traveling through the focus. Other directly focused towards the focus. Now after reflection, they travel parallel to the principal axis. Now see, this is the meeting point or converging of rays. Now here, our image will be formed. Right? Here, this is object. So this is image. So now by saying this, can you say where the image is formed? Between C and F or F and C. Or I can simply say in front of C. In front of C. Right? So now, position of image between C and F. Or we can say in front of C. When object is beyond C, image is in front of C. The image of object forms in front of C. For easy remembering. Okay. Now next nature, as usual, concave, no? Real. Okay. Inverted. Diminished. Not nearly to the point size, but smaller than the object size. Okay. That is, image size is less than object size. Okay, diminished. This is the second position. Now understood how to draw the ray diagrams? We are following this rules itself only. If they come parallel, make another ray, the reflected ray, to pass through the focus. If they travel towards the focus, make the reflected ray travel parallel to the principal axis. Okay, maximum these two conditions only we are using. Okay, now the position of image beyond C, easy to remember, in front of C. If object is beyond C, image is in front of C. Right? Now next, and the nature of image, real, inverted, diminished. Diminished means the size of image is small than the size of object. Clear? Now next. Now position 2 completed. Position 3. Position 3 on center of curvature. When object is placed on center of curvature. Center of curvature. First, as usual, on white drawing sheet, draw concave mirror, right? Principal axis, pole, focus point, center of curvature. Now object is placed on center of curvature. Now let us see the image position. Okay. First, a ray from the object parallel to the principal axis incident on the reflecting surface. What happens? Rule 1 says that it passes through the focal point. Finish. Next, make a ray to pass through the focal point. After reflection, rule 2, it travels parallel to the principal axis. So it travels, okay. It travels parallel to the principal axis. See. Okay. Two rules we are using better. One, parallel rays passes through the focus. Another rays passing through the focus after reflection travel parallel to the principal axis. Now image, here is the converging point. Image means what we defined in the video 2. Either the converging point or which appears to diverge. Now see. Where the image is formed, the position on center of curvature only. Okay, when object is on center of curvature, image also forms on center of curvature only. Right? Nature of image. One, it is real. Next, inverted. And of same size. Image size. Image size. Same as object size. Image size, both are of same size. Now first 3 completed. See. First one, infinity. So position of object is at focal point. And the nature is extremely diminished. Means almost point size. Okay. Now next, that is the size of image is very, very small than that of the object. Second one, beyond C means back of C, center of curvature. Image in front of C, that is between C and F we will get. And here the size of image is small than the size of object. Next one, third one, we get object on center of curvature. Right? So image also forms on center of curvature but inverted with the same size as that of the size of object. So real inverted image size is same as size of object. Now clear? Any doubts? Okay. If you have any doubts, you can message me. Okay. Now next, now third one completed. Let us go for fourth one. When object is placed between C and F, or I can say in front of C. I can say in front of C, between C and F. Now, as usual, concave mirror, pole, focus, center of curvature. We have to point everything, right? Now see. What we said, object is between C and F. Here is the object, right? Between C and F. Object is between C and F. Now, as usual, first what we have to draw? The parallel. After reflection, it passes through focal point. Next, what we have to do? A ray passing through focus. Now, after reflection, they travel parallel to the principal axis. Right? Now, here the converging is there. So, this is the image position. Where is the image? Beyond C. Now, did you see? In case 2, object is beyond C. Image is in front of C. In case 4, object is in front of C. Image is beyond C. Opposite. Quite opposite to each other. Right? You can remember in such a way. So, position of image beyond C. How it is? A real, right? Inverted and extremely big in size. Image big in size than object. This is the object size. This is the image size. Bigger than the object. Image formed is bigger than the object. Now next. Now next, fourth completed, fifth position. Fifth position at focus. Right? Very easy. Logically, if you remember, there will be no confusion. Right? Principal axis. Object is at F. As usual, first let us draw the parallel line. Okay? Right? Passes through the focus. Okay? Now next, let us draw another line. Assume it is passing through the center of curvature. Like this. After reflection, right, again retraces the original path. Now see, here when object is placed at focus, then image is formed at infinity. Position of image, infinity. Real, inverted, extremely big. Extremely big. Image size is extremely bigger than the object size. Position of image infinity. Now see case 1. When object is at infinity, image is formed at focus. And case 5. When object is at focus, image forms at infinity. Quite opposite. Alright. Now next one. When object is placed between F and P, as usual, don't forget to draw concave mirror. Concave mirror. We are talking for concave mirror. Here I already got. Now where the object is placed? Between F and P. Now one parallel rays. Okay. A little bit. Wait. One passing to the focal point. Okay. After reflection, After reflection, they travel parallel. Another parallel ray you draw. They will pass through the focus. Now we see these two rays coming behind the mirror. Right? Image position. Behind the mirror. Behind the mirror means, in 7th class you read, behind the mirror means virtual image and erect. Right? And more extremely big. Image size extremely bigger than the object size. Right? So, in form of table I will write and show you all 6 positions. Here we used the first 2 laws. When the rays are coming parallel to principal axis, they pass to the focal point. When rays are coming towards the focal point, after reflection, they travel parallel to the principal axis. This we used. Right? Now, serially. Okay? Object position. Right? Her next position of image. Next, nature of image. Right? No. At infinity. Now say at focus. Okay, 1, 2, 3, 4, 5, 6 positions. And nature, real, inverted, extremely diminished, very, very small. Extremely diminished in size. Now I will write 5th one for easy remembering. At focus. At focus, image position, infinity. A real, inverted, right? Extremely big. See, quite opposite. Infinity, image formed at, okay, infinity, image formed at focus. Size of the image, very small. When it is at focus object, image formed at infinity and size is extremely big. Here small, here big. Here focus, here infinity. Here infinity, here focus. Right? Now next. Next what we said? Beyond C. Okay. So beyond C means the position of image in front of C. For easy remembering, I am using this in front of C. Or we will say between F and C or C and F. And image, real, inverted, not nearer to the point size, little bit bigger, but smaller than object size. I am writing 4th. 4th one, in front of C. Or I can write between F and C. Right? Now opposite. Position beyond C. A real, nature, inverted, big size. Image size is bigger than the object size. Now see, these two are quite opposite. Beyond C, in front of C. If object is in front of C, image beyond C. Here small size, here big size. Now these two are completely different. Now on C. Image also at C only. Now real, inverted, object size, image size are same. Now sixth one. Between F and P, or I can say instead of P, curved surface. You can use curved surface between F and curved surface. Now it is formed beyond mirror. Beyond mirror means virtual image, erect and extremely big in size compared to that of the object size. So I hope it is easy to draw the ray diagrams and even easy to remember this. If you remember 1, 5, opposite pair, 2, 4, opposite pair. Just you learn 3rd and 6th. Easy to remember. Okay. And first two rules only maximum we used. Okay. Now let us move for the convex mirrors. Same rules, but the way of drawing diagram is different. That's it. Her rules are same. Convex mirrors. Her rule 1. Okay. Her rule 1. So rule 1, as usual, rays traveling parallel to the principal axis after reflection passes through focus point. But here what happens, let us see. Concave surface is polished. Convex is reflecting surface, principal axis, center of curvature, focus. Right? Sorry. Principal axis will be beyond the reflecting surface, beyond the middle. Focus, center of curvature, principal axis. Now rays coming parallel to the principal axis. Okay, they reflect. Incident ray, reflected. But what we see? As if this reflected ray appears from F. Rule 1 says that after reflection, they will be in such a way that they appeared from F. Okay. Now rule 2. Convex mirror. Right? Sorry. Concave must be polished. Principal axis. Okay. Focus. Center of curvature. Rays directly focused towards the focus. Okay. After reflection, they travel parallel to the principal axis. But the way of drawing the diagram is like after reflection, they travel parallel to the principal axis. Incident ray, reflected ray. A rule. Now, rule. Now, rule. Convex mirror. A center of curvature, focal point. The rays which are directed towards the center of curvature, after reflection, they retraces the path. Reflected ray, incident ray. After reflection, they retraces the path. Okay. So these are about ray diagrams related to concave and convex mirrors. Now let us see how the questions will be asked. In tomorrow's video, I will prepare some PPTs, questions. Just go through that questions and try to answer that questions. Okay. Now see how the questioning will be asked. You have to identify the mirror. He will say, complete the ray diagram. Complete the ray diagram. First, identify the mirror. What mirror? Concave surface is polished. So this is convex mirror. He will not give anything. We have to identify. Next, how the ray parallel to the principal axis. Parallel to the principal axis. Parallel to the principal axis means it appears to come from the focus point. It appears to come from the focus point. So we have, right? Now next, complete the diagram. Okay. Principal axis. He will not give anything. We have ray diagram. He gave like this. And he mentioned a focus point. Means these rays are directed towards the focus. Right? Directed. Sorry. Wait. I'm sorry. I have to draw that side. Here, like this. Okay. Complete the diagram. Identify the mirror. Convex surface is polished. Means this is concave mirror. Principal axis. Focal point. He will give C. Sorry, I forgot to place C. He will give C. Means here, this is focus point. Now complete the diagram means when they travel towards the focus point, after reflection, they travel parallel to the principal axis. If you are perfect with that 6, easily you can answer any question and you can complete the ray diagrams. And some questions, how it will be missed? Concave mirror, right? He will give focus, center of curvature. He will say, object is at center of curvature and draw the diagram. Complete the diagram. Now complete the ray diagram. Then object is at center of curvature means image is also at center of curvature. So one parallel line passes through the focus. Other passing through the focus. So whatever it may be, you have to draw the ray, right? Such that the meeting of rays must be at center of curvature only. So this is image. Arrows you have to mention compulsory. Okay, for ray diagrams, arrows shows the direction. So they play a vital role in drawing the ray diagrams. Right? Now, next question. Or sometimes, okay, I forget to say one thing. The symbolic representation of concave and convex. Sometimes, okay, means you have to understand this is concave mirror, focus, center of curvature. Object, he kept beyond the center of curvature means image in front of center of curvature. Complete the diagram. Okay. Like this, he will ask the questions in SSC. He also focus on the uses of convex and concave mirrors. He also may give some problems related to the focal length and radius of curvature relation, that is R equal to 2F or F equal to R by 2 in such a way. Okay. So, by this video, we completed the basics of chapter 1, grade 10, reflection of light at curved surfaces. So, within 2 days, I will post the 1-mark questions or the practice questions for checking yourself whether you understood this basics or not. If you like my video, share it, subscribe. Thank you for watching my videos. Yours, Reshma Physics.